Okay, so we're doing the final exam, not graded. So when you have something that goes only in one direction, starts and goes on forever and ever, it's called a ray. Now, you always have to have the hat on top of this look like a ray. Okay, so this is good, but oh, they all have like rays on the top. Okay, see that? You have to have that on top of the AB. If it said ray AB but it had a line segment on the top, that would be incorrect. You have to have this on top of the AB. Okay, so here, because it starts and stops, that's called a line segment, and you have to make sure it's a line segment on the top. Okay, so here it goes in both directions forever and ever and ever, so that means it's a line, and you have to make sure that it has the correct hat on the top. It goes, the symbol, okay, it goes on and on forever in both directions. So here, because this is bigger than 90 degrees, I always remember a big person for obtuse. Okay, so any big angle like this is called obtuse. Here, it's just a straight line, so this is called a straight angle. Here it says F. Where's F? Oh, this one's smaller than 90, so here's 90 degrees. So anything smaller than 90 degrees is like a cute baby. It's small like a cute baby. So acute, okay, a cute baby. Anything smaller than 90, oh, there's another one, acute baby. Okay. Here, this one would be a good one for building a house with. So this one is called a right angle. The right one to build a house with. So this, again, this is straight, so we call it a straight angle. So here we have the word complementary and supplementary. To help you remember, this has 2 P's, this has 1 P. So here, two angles that add up to 90 degrees are complementary, and bigger, 2 P's, 2 angles that add up to 180 degrees is supplementary. So complementary is 90, supplementary is 180, and we just subtract this. Oops, I forgot the 0. Oops. So here, 90 minus 80.3. So that means I have a 90 degree angle. One angle is 80 degrees and one angle is almost 10 degrees. Okay, those 2 angles add up to 90. Okay, this one down here, I have 180 degrees, which is a straight angle, or you can think of it as half of a circle. One angle is 45 degrees, and that means the other angle is 135 degrees. Both of these angles, if I add them together, it equals to 180. So the trick is to remember 2 P's is the bigger one, 1 P is the smaller one. Okay, so the complementary here is 9.7 degrees, and here it's 135 degrees for the supplementary. So this question looks complicated, but it's not. There's really only 2 angles in here. When you have 2 parallel lines cut by a transversal line, it just makes 2 angles, a small angle and a big angle. Okay, so if I look here, it says if the measurement of angle 8 is 49, so let's find 8. So this is 49. So if I look at 8 and 1, and you're thinking slices of pizza, which slice is bigger? The slice 1 or the slice 8? Yeah, 8 is small and 1 is big. So here the small angle is going to be 49 degrees. The big angle, how much is the big angle? Well, that's half a circle. That's a straight angle, which means it's 180 degrees. So I can go 180 degrees minus 49. Let's see what that is. 131. Let's make that 49. that means all the big angles are 131 and all the small angles are 49. So let's just find them with our eyes. Well, 4 looks small, so that's 49. 5 looks big, so that's 131. 6 is small, which is 49. And remember, see, they're opposite each other, so they're the same. Opposite each other, so they're the same. And that one's big. 2, that looks small, and that looks big, so 131. So now it says, which ones are all the small angles? So let's look. Angle 4 is small, angle 6 is small, angle 2, is that a 2? Yeah, 2 and 8 are small. So let's 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. So it's not this one, so it's, these ones are all the small. So now which ones are big? 1 is big, 3 is big, 5 is big, 7 is big. So now 1, 3, 5, 7, 1, 3, 5, 7, 1, 3, 5, 7, 1, oh, here. It says 131. That's 141. That's not correct. That's not correct. Here, 1, 3, 5, 7 is 131 degrees. So it's got to be this one, because 2, 4, 6, 2, 4, 6, these are small. They're not telling you 8 because they already gave you 8. And then the big ones are 1, 3, 5, 7, and it's 131 degrees. Okay, there. Okay, so here, it says, what's the name of this polygon? So this one is difficult because it's a weird shape and it can look different. But whenever I see it looking like something I would plant a flower in, like a flower pot, it's a trapezoid. So it has to have 4 sides. 2 sides are parallel. And then these can be like anything. This could go out, this can go in. It could be upside down, it could be short like this. It could be like this. It could be like this. It doesn't matter. As long as these two are parallel, okay, these can join any way they want. Okay, so it's difficult to find a trapezoid because they kind of all look different. But if it looks like a flower pot, then it's a trapezoid. So is it regular or not? Regular means all the sides and angles are the same. So it has to look pretty. Like in this here, it doesn't look everything exactly the same. If I had 4 sides and everything exactly the same, it'd be a square. All the sides the same, all the angles the same. Okay, so it's not regular. Let's draw another one. Like a stop sign. Okay, that's not so pretty, but if I had it something like this, all the sides are kind of the same, all the angles are kind of the same. I mean, they have to be exactly the same, but I'm drawing it and it's kind of bad. But they're supposed to look all the same. Or here, an equilateral triangle. Here the sides are the same and the angles are the same. Okay, that's regular. So this is not regular. So here we have 4 sides and everything looks exactly the same, so it's a square. And because everything looks exactly the same and the angles look all the same, it's regular. Okay. Now this picture's bad because it looks like that the angles are slightly different, but it's only the drawing that's bad. Here it says these 2 lines, they all have 2 lines, which means they're all exactly the same sides, which means all the angles are the same. They're trying to draw an equilateral triangle where everything is the same. So this is a triangle, but because everything is the same, it's an equilateral triangle because they're equal. All the sides are equal, so it's an equilateral triangle. Now I look at all the angles, and because all these angles inside are small, they're cute like a baby. It's an acute triangle. If I had a triangle that looked like this, that means I'd have one angle that's big so obtuse. Okay, so if I had one angle that was big inside there, then it would be an obtuse triangle. Okay, if I had one angle inside there that's a right angle, then I'd call it a right triangle. So here everything is equal, so we call it an equilateral triangle. And everything here is small, 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 so they're all acute like a baby. So it has to be B. Okay, isosceles means I have two the same and one different. So isosceles, I remember it because there's two S's. Two sides the same and one different. I saw Isosceles, I saw Miriam, I saw Fahad, I saw Isosceles. Okay? Scalene means all the sides are different. This one is different size from this one, and it's different from this one. Okay? Let's look at this. Oh, these two are the same, and this one is different. So we have to have the isosceles. Two the same. So here these are two the same. So this is isosceles, and all these angles inside are small, so they're cute like a baby.